Welcome back, chemistry fans. Getting a little heavy with the acid details. So let's try this homework. I'm not confident that it's something that is within everyone's means, but hopefully with a little explanation here, you're going to feel a lot more comfortable afterwards. So the first one, very, very simple. It's going along with the nomenclature discussions that we had in class, whereby we need to understand that this is a ternary. It's got a polyatomic ion in the compound. And so we need to be able to recognize this SO4 as being sulfate, ATE. Anytime we have an ATE ending, it will take the IC as an acid. The ITE polyatomics would take the OUS. So we don't have any kind of prefixes. It's not binary. So this just becomes sulfuric acid. Okay. Now we've got question number 2 here, and it is dealing with the pH whenever we are given an acid, a Ka value, and we're given the initial amounts here. Okay. So what we have is a Ka, which is essentially the products over the reactants. The products in this case is going to be the material that does not have the H over the material that does have the H. So we have given to us the material with the H's included. We have the Ka value. So what we've got to do is solve for this up here, and that will in fact then tell us what the concentration of hydrogen is, which we can then plug into a pH value. So it's convoluted, it's got a lot of steps. Let's see if we can make this work. Okay, so I have a Ka value of 3.9 times 10 to the negative 6. It is equal to, we don't know the hydrogen concentration. We do know, however, underneath it, we do know the initial concentration is 6.2. Now, because we know that these ratios are going to split apart into the equal concentration amounts, we can simply make this x squared. All right, so let's simplify this. 3.9 to the power 3.9 to the power of negative 6 times 6.2. That's going to give me 2.42 times 10 to the negative 5 is equal to x squared. So then I'm going to do the square root of that value to get my x, and that's 0.0049. Now that is in fact my hydrogen ion concentration, 0.0049. So now we could plug this into our pH formula. pH is equal to negative log of hydrogen ion concentrations. So we'll do negative log of that value, and you end up with 2.31. 2.31. That's a lot of details for you to try and manage. Okay, now on number 3. What if, however, instead of just having an unknown product amount, what if they go ahead and tell you what that product amount is? What if they tell you that this is a buffering solution? What if they give you 2 materials that you got to add together, and both of them appear to be some form of an acid? So what we have to do is figure out how to manage this using a similar equation, but not quite the same one. Okay, so to understand what's happening, we have to look at the nature of this NH3 and this NH4. NH4 is going to donate a hydrogen. That's just the nature of this NH4. It's something that you're going to have to start to recognize. And the nature of the NH3 is that it is going to accept a hydrogen so that it can become NH4. Now, how did you know that? That's only through experience, that you're going to have to understand that NH4 is desirable. It's not going to go to NH5. It's not going to go down to NH2. So this then tells you the nature. If it's accepting of a hydrogen, that means that it is the base and that this is the acid material in this buffering solution. So how we deal with this, we have pH, it's the Henderson-Hasselbalch equation. pH is equal to the pKa plus the log of the base over the acid concentrations. So what we've got is a Ka value that we've got to convert into pKa. So I'm going to put 5.5 times 10 to the negative 10. I'm going to do now the power of that. So I've got to do the negative log of that value. And that's going to give me 9.26 plus the log of the base value, which is the NH3 0.75 over 1. So the log of 0.75 divided by 1 is negative 0.125. So this is not going to change my value a whole lot as far as what the pH is. It's just going to change it a little bit. So I've got 9.26 minus 0.125, and that gives me a new pH of 9.135, which this is the purpose of a buffering solution, is that it adds material, but it doesn't allow the pH to change very much. If you had a big change, you know that you've done something wrong. All right. This is everything that I wish for you to be able to talk to me about with our homework. Thank you so much. We'll talk to you again soon. Bye-bye.